Welcome to School of Advanced Chemistry. I am Khidr Chuktai. Today I am going to explain 20 typical MCQs regarding Kc and Kp for AS Chemistry students since 2015 to 2021. Let's get started. I am going to start from this question that is taken from October-November 2021. The equation shows H2 and I2 react to form an equilibrium mixture. H2 plus I2 goes to 2HI, and enthalpy change for this reaction is minus 9.6 kilojoules per mole. A mixture containing equal amount of H2 gas and I2 gas is made at temperature T1. The composition of the mixture is monitored. A graph of the result is shown. Here is the graph. Mole fraction of I2 on y-axis and time on x-axis. Initially, from this graph, you can see that initially we were having 0.5 mole, this one, 0.5 mole of I2, and at the stage of dynamic equilibrium, at the stage of equilibrium when the reaction is complete, at that time the mole fraction of iodine is equal to 0.23. Once again, this reaction is an exothermic reaction. So, this experiment is repeated at lower temperature, that is said to be T2. By lowering the temperature, what will happen to the equilibrium status, dynamic equilibrium, or the position of equilibrium of this reaction? Let's see over here. It's an exothermic reaction. This forward reaction is exothermic reaction. It means that its reverse reaction will be endothermic reaction. By lowering the temperature, by decreasing the temperature, equilibrium will shift towards the right hand side. The right hand side, decrease in temperature favors the exothermic side of the chemical reaction. So with the passage of time, this I2, the concentration of this iodine will decrease, and there will be more concentration of hydrogen iodide. So it means that with the passage of time, till the new equilibrium is established, its amount, its mole fraction, or its mole, that is one and the same thing. You can say mole fraction is a gesture of the mole at the time of dynamic equilibrium. You can say that. So the amount of iodine will decrease with the passage of time. So which one graph is the correct one? A, it's having still 0.23, so it is incorrect. B, yes, now the amount of iodine that is decreased from 0.23, it is the correct one. Again, this C is showing the same amount as that of the first equilibrium position. No, it's wrong. And D is also wrong because there is no any sort of increment in the quantity of iodine because reaction is moving right hand side, towards right hand side. So B is the correct option. B is the correct option. The next question that is taken from May, June 2021. Nitrogen reacts with hydrogen to produce ammonia. Nitrogen plus hydrogen goes to 2NH3. A mixture of 2 mole of nitrogen, 6 mole of hydrogen, and 2.4 mole of ammonia is allowed to reach equilibrium in a sealed vessel, the volume of 1 dm³. It is found that 2.32 mole of nitrogen were present at the stage of dynamic equilibrium. So in this case, this is a typical reaction, you can say, in which all quantities of all species are present. Reactants are present initially, and the yield, the compound that is going to be formed, that is supposed to be formed, is also present initially. Ammonia is present in that reaction mixture. Nitrogen is present. Here is the nitrogen. Hydrogen is present, and so on. So in this case, we will have to check the direction of the reaction first. I'm going to write it again over here. N2, 3 mole of H2 goes to 2NH3. Initially, nitrogen was 2 mole, hydrogen is equal to 6 mole, and ammonia is equal to 2.4 mole at the commencement of the reaction. At the stage of dynamic equilibrium, we have seen that nitrogen has become 2.3 mole. Nitrogen has become 2.32 moles. So it means that reaction is moving. Initially, nitrogen was equal to 2 mole. When the reaction is finished, the mole of nitrogen has become 2.32 mole. I mean nitrogen, the concentration or the mole of nitrogen has been increased. So reaction is overall moving in a backward direction toward the reactants. So I am going to write the expression. If the reaction is moving on the left hand side, so I'm going to write it over here. 2.40 minus 2y. This is the change in mole. I mean, overall reaction is moving in backward direction. Here, initial mole of hydrogen is 6 plus there must be the 3y. That is, y is the mole change in moles. And comma, for nitrogen 2 plus 1y. We have seen that the amount of nitrogen at equilibrium, that is equal to 2.32. So 2 plus 1y is equal to 2.32. I mean, y is equal to 2.32 minus 2 and y is equal to 0.32. So put the value of y, that is equal to 0.32, 0.32. We will get the mole of nitrogen 2.32, and what about 6 plus 3 into 0.32 goes to 2.4 minus 2 into 0.32. So the mole of nitrogen at the stage of equilibrium, that is given 2.32. What is the remaining mole of hydrogen at the stage of dynamic equilibrium? So, 6 plus 3 into 0.32, and the answer is 6.96. Hydrogen is 6.96 moles at the equilibrium. And finally, the mole of ammonia at the stage of dynamic equilibrium will be 1.76. 1.76. So these are the number of moles at the stage of dynamic equilibrium. As the total volume is equal to 1 dm cube, so divide by 1 dm cube, divide by 1 dm cube, divide by 1 dm cube. Now, this answer is in mole per dm cube. We have changed mole into mole per dm cube, in concentration. Now come towards the expression of Kc for this reaction, that is equal to right hand side, that is NH3 raised to power 2 divided by nitrogen raised to power 1, concentration of nitrogen raised to power 1 and concentration of hydrogen raised to power 3. What is the answer of NH3? What is the concentration of NH3? That is 1.76 raised to power 2. In case of nitrogen, 2.32 raised to power 1. The hydrogen is 6.96 raised to power 3. So this is the expression, and which one is the correct option? A is the correct option, correct answer. Next question. May, June 2021, ethanol combined with ethanoic acid to form ethyl ethanoate according to the following reaction. Ethanol plus ethanoic acid goes to ethyl ethanoate plus H2O, and delta H is equal to minus 6 kilojoules per mole. 9.2 gram ethanol, 12 gram ethanoic acid, and 8.8 gram ethyl ethanoate are mixed and allowed to stand at 298 Kelvin, at room temperature, until equilibrium is reached. MR of ethanol is equal to 46, ethanoic acid is equal to 60, and this ethyl ethanoate is 88. The resulting equilibrium mixture is found to contain 4.8 gram of ethanoic acid. Once again, initially, we are having this ethanol 9.2 grams, it's 12 gram, it's having 8.8 gram, and so on. Once again, we are having the quantities of the both components, reactants as well as the products. So once again, we will have to check the direction of the reaction. Initially, this carboxylic acid is 12 gram, right? But at the stage of first equilibrium, its quantity is 4.8 gram. It means that it's losing its mass. So equilibrium, I mean the direction of the reaction is moving towards the forward direction, Now I'm going to find the moles. 9.2 divided by 46, it's ethanol, plus 12 divided by 60 mole of carboxylic acid, and the rest of as ester, that is 8.8 gram, and its mass MR is 88. So I'm going to find the mass of each substance. 9.2 divided by 46, and the answer is 0.2 moles, comma, you can write as well 12 divided by 60, and the answer is again 0.2 moles, goes to 8.8 divided by 88, and the answer is 0.1 mole. So initially, there was 0.2 mole of ethanol, 0.2 mole of acid, and initially there was 0.1 mole of this ester, that is ethyl ethanoate. After the stage of equilibrium, or the state of equilibrium, 0.2 minus y, 0.2 minus y, and it will be 0.1 plus y. So what is the final mole of the remaining mole at the stage of dynamic equilibrium for the carboxylic acid, for ethanoic acid? I mean, we are going to find the remaining mole, 4.8 divided by 60. These are the mole of remaining ethanoic acid at the stage of equilibrium. 4.8 divided by 60, and answer is 0.08 mole. So it means that 0.2 minus y, its answer is 0.2 minus y is equal to 0.08, and you can say that y is equal to 0.2 minus 0.08. (0.2 minus 0.08), and the answer is 0.12. So y is equal to 0.12. Put y equal to 0.12, 0.12. Its answer is 0.08 at the stage of dynamic equilibrium. Its answer will also be 0.08, and its answer will be 0.1 plus 0.12. That will be equal to 0.1 plus 0.12, and it will be 0.22 moles. So 0.08 mole of ethanol is present, 0.08 mole of carboxylic acid is present, 0.02 mole of this quantity, that is this substance that is said to be ethyl ethanoate, is present. So now come toward the option. This experiment is repeated 323 Kelvin, that is the higher temperature, Which statements are correct? There are 0.22 mole of ethyl ethanoate in the mixture at equilibrium, first equilibrium at 298. Yes, we have calculated. The answer is 0.22 mole. The first one option is the correct one option. The equilibrium mixture at 323 Kelvin at higher temperature will contain more than 4.8 gram of ethanoic acid. The forward reaction is exothermic, backward or the reverse reaction is endothermic. By raising the temperature, equilibrium will shift towards the backward side, towards the left hand side. So yes, it is true that there will be more amount of, as the reaction is going to the reverse, so it will increase the quantity of carboxylic acid, it will increase the quantity of the ethanol that is present at the stage of dynamic equilibrium. So by reversing this equilibria, we will have the more quantities of these both reactants. So yes, it is true, there will be more mass of ethanoic acid at the new equilibrium when the temperature is 323 Kelvin. If a small amount of water is added at the start of either experiment, the value of Kc would not be affected. Yes, it is true. The value of Kc, the answer of Kc is affected only by changing the temperature. So once again, this third one is also the correct one. And 1, 2, 3, all are the correct options. The next question is, that is taken from March 2021. A sample of 17.15 mole HI is in dynamic equilibrium with 2.27 mole H2 and 2.84 mole I2 in the volume of 1 meter cube at 764 Kelvin and 141 kilopascal. H2 plus I2 goes to 2HI. All substances are the gaseous one. Two equilibrium constant Kc and Kp can be calculated for this reaction mixture. Which statements about the equilibrium constant for this mixtures are correct? Neither Kc nor Kp has any units. Let's see. I'm going to find the answer of Kc. Going to write the expression of Kc. Here, substance that is present on the right hand side must be in numerator. Hi raised to power 2 because of here is the 2 mole divided by H2 raised to power 1 multiplied by I2 raised to power 1. So the number of brackets in numerator and denominator are equal. So if the brackets are equal, so they will cancel out and there will be no unit for this reaction. For this Kc, for the reaction of this Kc, no unit. Yes, it is true. Kc is having no unit. Now I am going to write the expression for Kp. Kp is equal to pressure of the species present on the right hand side. Yes, that is the gaseous one. Hi, pressure is only applicable for the gaseous substances. So pressure square for Hi, pressure raised to power 1 for H2 is a gas, and multiply by pressure for the iodine, that is also in form of a gas. So 1 again, pressure will cancel out, and again there is no unit for Kp as well. So the first one option is the correct option. The next one is Kc is equal to 45.6. If there is no unit of Kc or Kp, then there is no need to find the concentration of the substances to calculate the Kc, right? There is a shortcut method. If you are having no units for that reaction, then there is no need to convert this volume. You can simply put these moles. These are at the stage of dynamic equilibrium. At the time of dynamic equilibrium, Hi is equal to 17.15 mole, and this hydrogen is 2.27 mole, and iodine is 2.84 mole. I am putting these values, just the moles, not going to put in form of concentration. So Kc, first of all, I am going to find the answer of Kc. Kc is equal to mole of Hi, that is equal to 17.15 raised to power 2 divided by mole of H2. I am not going to change them into the concentration. Mole of H2, that is equal to 2.27 raised to power 1 multiplied by the mole of iodine, 2.84 raised to power 1. Answer will be the same if I am going to put the concentration or I am going to substitute or put the moles. Answer will remain unchanged. So 17.15 and its square is equal to 294.12. 294.12 divided by 2.27 multiplied by 2.84, and the answer is 6.44, almost 6.44, and 294.12 divided by the answer, and that is 45.6. Yes, it is true. its value of Kc is 45.6. It is also true. The next one is the Kc, answer of Kc is higher than that of the Kp. So in case of Kp, we need partial pressure. Once again, this Kp is also having no unit. There is no any sort of unit. So there is no need to change this mole into the partial pressure. Once again, there is no need to change the moles into the partial pressure. That is a hectic mechanism, So what will be the Kp? I think the answer will be the same. The pressure of HI is roughly equal to the pressure mole. Mole of HI 17.15 raised to power 2 divided by pressure of hydrogen is because of its mole. You can say pressure of iodine is because of its mole 2.84 and similar one, and again its answer will be equal to 45.6. This is incorrect. These both Kc is equal to Kp in this case. So 1 and 2, there are the only two correct options. The next question that is taken from October, November 19. The reaction between sulfur dioxide and oxygen is reversible. 2 mole of SO2 plus 1 mole of O2 goes to 2 mole of SO2 and Kc. The answer of Kc is given this time. This time answer of Kc is given. It means that this reaction is, this question is quite easy to solve. In the equilibrium mixture at 1000 Kelvin, sulfur dioxide concentration is 0.2 mole per dm cube and the oxygen concentration is 0.1 mole per dm cube. SO2, the concentration of SO2 is equal to 0.2 and the concentration of oxygen is 0.1. What is the sulfur dioxide concentration? So if the Kc is given, then simply write the expression. Kc is equal to concentration of SO3 raised to power 2 because of this 2 mole and divided by SO2 raised to power 2 multiplied by O2 raised to power 1. So we are supposed to find the concentration of SO3. Let its concentration is equal to X. X raised to power 2, X square divided by the concentration of this SO2 that is 0.2. 0.2 raised to power 2 multiplied by the concentration of oxygen is equal to 0.1 raised to power 1. And the answer of Kc is equal to 280 x square 0.2 square into 0.1. 280 into 0.2 square into 0.1 is equal to x square, and x will be equal to 280 into 0.2 square into 0.1 whole under root. So this answer will be equal to the concentration of the sulfur trioxide. That is equal to 1.058. A is the correct option. A is the correct option. The answer of this X is equal to 1.058 mole per dm cube. The next question that is taken from October, November 21, I think. In this question, you should assume that all gases behave ideally. And this question is, I think, not, let's solve it. Hydrogen and iodine react reversibly in the following reaction. The system reaches dynamic equilibrium. Yes, it is the relevant question. H2 plus I2 goes to 2HI and delta H is equal to minus 9.5. Which statement must be true? Must be true, always true, for the Kp for this equilibrium to be constant. The partial pressure of H2, I2 and HI are equal. They may be, they may not be. So this is not the always true. External pressure is constant. Yes, it may be or it may not be. This is not the case always. The forward and reverse reaction have stopped. No, in the dynamic equilibrium, reaction, forward and reverse reaction, they never stop. Reaction remain in movement, in motion. That's why it is said to be the dynamic equilibrium. So the last one will be the correct one. The temperature is constant, yes. Because the value of the temperature, the rise and or the fall of temperature affect the value of this Kp. Kp is affected by the value of temperature only. So yes, D is the correct option. Next question. Hydrogen iodide dissociates into hydrogen and iodine. 2 mole of Hi goes to H2 plus I2. In an experiment, B mole of hydrogen iodide were put into a sealed vessel at a pressure P. At equilibrium, X mole of hydrogen iodide had dissociated. Initially, it was equal to, B. It was equal to B. Initially, there were 0 mole of hydrogen and 0 mole of iodine. I'm going to write it over here. 2Hi goes to H2 plus I2. All substances are the gaseous. So initially, B moles of Hi were kept in a sealed container. Initially, H2 was equal to 0. There was no hydrogen and iodine, 0 for iodine. At the stage of dynamic equilibrium, the total pressure is equal to P. At dynamic equilibrium, X mole of hydrogen iodide had dissociated. So B minus 2Y goes to 0 plus Y, comma 0 plus Y. This Y is the change in moles. Moles changing from Hi, minus 2Y, it will be in the ratio of, in the multiple of 2 minus 2Y. And there is, increment of the mole. There is increase in the mole of hydrogen and iodine. So plus Y with respect to their coefficients in the balanced chemical equation. 0 plus 1Y, 0 plus 1Y, you can write it over here. According to the statement, X mole of hydrogen iodide had dissociated. Which quantity is going to dissociate? That is equal to 2Y. So indirectly speaking, 2Y is equal to X according to this said statement. 2Y is equal to X, and Y will be equal to X by 2. So put Y equal to X by 2, X by 2. B minus 2 into X by 2, you can say 0 plus Y, 0 plus X by 2, comma, again it will be X by 2. So B minus X is the mole of hydrogen iodide at the time of dynamic equilibrium, and X by 2 is the mole of hydrogen at the time of dynamic equilibrium, and X by 2 is the mole of iodine at the time of dynamic equilibrium. Total mole, as which expression for the Kp is correct? We are supposed to find the answer of its Kp, so there is need to find the partial pressure. So first of all, I am going to find total moles. Total mole, B minus X plus X by 2 plus X by 2, that is equal to just B. This whole X expression will cancel out, and that is equal to B. That is equal to B. Now come towards the mole fraction and the partial pressure. The partial pressure of Hi will be equal to partial pressure. That is equal to the mole fraction of Hi. The mole of Hi, B minus X, divided by total mole, that's equal to B, multiply by the total pressure, that is equal to P. So it will be P into B minus X over B. Same is the case, partial pressure of H2, X by 2 mole of hydrogen is over here, divided by B and whole multiply by the total pressure, that is equal to P. Same is the case for the partial pressure of iodine. X by 2 divided by B into total pressure, that is P. So we are having this sort of expression. We can simplify this expression as well, X by 2 B into P. This can be expressed like that. So it's a mole fraction, a partial pressure, sorry, of hydrogen. It's also the partial pressure of iodine as well. So I'm going to find the answer of Kp. Kp is equal to the species present on the right hand side will be in numerator, and I mean it's equal to X, this one, Xp over 2b multiplied by Xp over 2b, and divided by, that is equal to the partial pressure of hydrogen iodide, that is P, I'm going to write it over here, divided by P B minus X divided by B whole square, because it's having 2 over here. So this is the true expression. Let me erase the additional calculation. Okay, now what is the answer of this Kp? It's equal to X square P square 4 into B square divided by, P square B minus X square over B square. It can be written as X square P square over 4B square multiplied by, it will be changed into, B square over P square B minus X square. So B square will be cancelled out, P square will be cancelled out, and remaining answer will be equal to X square, X square divided by 4 into B minus X square. And D is the correct option. D is the correct option. A mixture of nitrogen and hydrogen gases at temperature 500 Kelvin was put into the evacuated vessel volume, that is 6 dm³. The vessel was then sealed. Nitrogen plus 3 mole of hydrogen goes to 2 mole of Ni3. The mixture was allowed to reach a dynamic equilibrium. It was found that 7.2 mole of N2 and 12 mole of hydrogen were present in the equilibrium mixture. Initial moles, we are not having the initial moles, we are just having the moles at the stage of dynamic equilibrium. The value of equilibrium constant Kc, once again Kc is given, this is the simple question. I'm going to write the expression of Kc. Concentration of NH3 raised to power 2 divided by concentration of N2 raised to power 1, concentration of hydrogen raised to power 3. What is the concentration of ammonia present at the equilibrium mixture? So we are supposed to find the concentration of NH3. Once again, let's suppose the concentration of NH3 is equal to X. So we can write it over here, X square divided by, what is the concentration of nitrogen at the time of dynamic equilibrium? 7.2, and here is the dm³, 7.2 over 6 dm³. That will be the answer of concentration. 7.2 divided by 6, that is equal to 1.2 dm³. 1.2 dm³ raised to power 1. What is the concentration of hydrogen? 12 divided by 6, 2, and it's a 2 dm³, 2 raised to power 3. The answer of Kc is equal to 6 into 10 raised to power minus 2. 6 into 10 raised to power minus 2. So X square is equal to 1.2 into 2 raised to power 3, 8, multiplied by 6.6 into, or 6.02 into 10 raised to power minus 2. Here is the answer, and then we will take its under root. That will be equal to the exact answer. So what is the answer? 1.2 multiplied by 8 multiplied by 6.0 10 to the power minus 2. And here is the answer. The answer is 0.75 9. I mean 0.6 mole per dm cube. B is the correct option. B is the correct option. The next question, X, Y, and Z on all gases behave ideally and react according to the equation below, shown below. X plus 2y goes to Z. When 3 mole of X and 3 mole of Y are placed inside the container, a volume of 1 dm cube, they react to make the maximum amount of Z. Unfortunately, that is not the question regarding Kc, Kp. However, I'm going to solve it. The final temperature of the reaction vessel is 120 degrees Celsius. What is the final pressure inside the reaction vessel? Initially, X plus 2y goes to 2Z. I mean the mole of X is equal to 3 mole. The mole of Y is equal to also 3 mole, and we are going to find the answer of this Z, mole of Z. You know that if we are given the quantity of the both reactant, we will have to find the limiting reactant first. Its mole, the mole of X is equal to 1 divided by 1. Mole of Y is equal to 2 according to this balanced chemical equation, so divided by 2. Its answer will be 3 and its answer will be 1.5. So this one is the lower answer, and it means that this Y is the limiting reactant. So this Z, I mean, it will be equal to 0 at the end of a chemical reaction, and answer of the final answer of Z will be based on the mole of Y used, right? Okay. If we are using 2 mole of Y according to this balanced chemical equation, 2 mole of Z is formed. If we are using 3 mole of Y, how much mole of Z will be formed? Exactly 3 mole of Z will be formed. Now, as you know, X is in excess, and what will be its remaining quantity? You can say 2 mole of Y will use its half, 3 mole of Y will use its half, I mean 1.5. So 3 minus 1.5, remaining X, quantity of the remaining X mole will be equal to 1.5. So at the end of chemical reaction, total number of mole of all gases will be equal to 3 plus 1.5. That is form that remain unreacted, and 4.5 is equal to the moles. Now we can find the final pressure. Pressure, I mean, we are going to suppose these all gases are behaving ideally, and P is equal to N into R into T divided by V. P is equal to number of mole, that is equal to 4.5, R 8.31, temperature must be in Kelvin, and I mean 120 plus 273 is equal to 393 divided by the volume, and volume should be in meter cube. I mean 1 divided by 1000. It's equal to 10 raised to power minus 3. You can say that 1 into 10 raised to power minus 3. So what is the final answer? Let me check it. 4.5 multiplied by 8.31 multiplied by 393 multiplied by, you can see 1 into 10 raised to power 3, and the answer is 1.47 10 raised to power minus 10 raised to power 7. 1.47 10 raised to power 7 is the correct answer. So I mean in this way you can calculate the exact answer in the Pascal. The next question is this one. SO2 react with oxygen to make 2 mole of SO3. In the equilibrium mixture at 1000 Kelvin, sulfur dioxide concentration is twice the oxygen concentration. Once again, Kc is given. I mean this one, the easier one. What is sulfur dioxide concentration? The similar method will be used in this case. Kc is equal to, first of all, write the expression of Kc. Kc is equal to SO3 raised to power 2 divided by SO2 raised to power 2 and multiply by O2 raised to power 1. And the answer of Kc is given, you know. Answer of Kc is equal to 280 once again. And SO3, what is the concentration of SO3? This time SO3 is given, that is 6 mole per dm cube. 6 raised to power 2 divided by the concentration of sulfur dioxide is twice as the oxygen. Let's suppose the concentration of oxygen is equal to X. So at that time, the concentration of SO2 will be equal to 2X. So I'm going to put 2X over here, raised to power 2, X for oxygen raised to power 1. So we can write as, 4X square into X, and you can write 6 square of 6 is equal to 36 divided by 280. And we can also write 4x cube is equal to, again this one, 36 divided by 280 divided by 4 on both sides. Let me check it over here. 36 divided by 280 and 0.128, 0.128, I think, yes, 5. That is equal to 4x cube and divided by 4 on both sides, divided by 4, and its answer is x cube is equal to 0.128 over 4, taking cube root. So, this x is equal to this one, and the answer of x is equal to 0.317 something 48, like that. So the appropriate option or answer is equal to C. Answer is the correct answer. The next question, gases X and Y react to form Z. An equilibrium mixture of these 3 gases is compressed at constant temperature. What will be the change in the mole fraction Z in Kp? Equilibrium mixture of these gases is compressed. Compression means we are going to increase the pressure. 2 moles, overall total number of moles on the left hand side is equal to 2 moles. Here the mole is equal to 1 mole. So by increasing the pressure, equilibrium will shift towards the right hand side. What will be the change in the mole fraction of Z? Z will be, its mole fraction, its number of mole will be increased, and so on. And the Kp, what is happening to the Kp? Kp will remain unchanged because Kp is changed or affected by the temperature only. So it is, no change. B is the correct option. Next question. Hydrogen and carbon dioxide gases are mixed at 800 Kelvin. A reversible reaction takes place. H2 gas plus CO2 gas goes to H2O gas, like steam, and CO gas. At equilibrium, the partial pressure of H2 and CO2 are both equal to 10.0 kilopascal, and Kp is given, that is 0.288. Once again, the Kp is given, this simplest question or simple question you can say. So, what is the question? What is the partial pressure of CO in the equilibrium mixture? Once again, I am going to write its expression. Kp is equal to partial pressure of H2O multiplied by partial pressure of CO divided by partial pressure of H2 into partial pressure of CO2. Partial pressure of H2 and CO2 both, that is equal to 10 kilopascal. So H2 and CO2, partial pressure of H2 is 10 raised to power 1 multiplied by CO2 is 10 raised to power 1, and we are supposed to find the partial pressure of CO, right? So these both are having same mole ratio. Their partial pressure will be equal. Let's suppose the partial pressure of H2O is equal to X. Same is the true for CO. its partial pressure will also be equal to x. So we can write over here the partial pressure of these two. Let's suppose its partial pressure is equal to x and the other one is also having x. So x square over 10 into 10, 100, that is equal to 0.288, that is the value of Kp. And x square will be equal to 0.288 multiplied by 100, and x will be equal to 0.288 multiplied by 100 whole under root. 0.288 into 100 and under root answer, that is equal to 5.3666. A is the correct option. 5.37 almost. Next question. A reaction involved in the contact process is shown. 2 mole of SO2 plus O2 goes to 2 mole of SO3. Delta is equal to minus 197 kilojoules per mole. The reaction is investigated at 200 kilopascal and 700 Kelvin. The value of equilibrium constant Kp is found to be Y. The reaction is then investigated at 1000 kilopascal pressure and at the same temperature as that of the previous one. The value of Kp found to be Z, right? Now come towards the options. Which statement comparing Y and Z is correct? Y and Z are the same. Y and Z are the same. Yes, it will be the same. You can see that changing the pressure, the Kp, the answer of Kp will not be changed. Kp and Kc is dependent or can be changed by changing the value of temperature, right? So by changing the pressure, there will be no change. Y and Z, the answer of Y and Z will remain same. So A is the correct option. Next question. Methanol can be produced from hydrogen and carbon monoxide. 2 mole of H2 plus CO goes to methanol. What is the expression of Kp for this reaction? Once again, a simple question. Kp is equal to substance or the species present on the right hand side. If it is in form of a gas, so partial pressure of CH3OH divided by the partial pressure of hydrogen raised to power 2 multiplied by the partial pressure of CO raised to power 1. So which one is the correct option? This one. This C is the correct option. This is the correct option. Right. Next question. Equilibrium constant Kc for the reaction shown is 2 per mole per dm at 600 Kelvin. N2 plus 3H2 goes to 2. NH3 is the equation, reaction. What is the concentration of NH3 at equilibrium? Once again, he is asking to find the concentration, and Kc is giving, I am going to write the expression of Kc, that is equal to NH3 raised to power 2 divided by H2 raised to power 3 and N2 raised to power 1. So Kc is given and we are supposed to find the concentration of NH3. Let's suppose the concentration of NH3 is equal to X. So X square divided by what is the concentration of nitrogen and hydrogen. Both are having same value, 2 mole. 2 raised to power 3 into, once again, 2 raised to power 1. And the answer of Kc is also equal to 2. So X square is equal to 2 raised to power 3 into 2 into 2. Right? Into 2 raised to power 3 into 2. So 8 into 2, 16, 16 into 2, 32. X raised to power 2 is equal to 32. And what will be the answer of X? Under root of 32. Yes, it is correct. C is the correct option. Right. The next one is, when a sample of HI is warmed at a particular temperature, the equilibrium below is established. 2HI goes to H2 plus I2. At this temperature, it is found that the partial pressure of HI is 28 times the partial pressure of H2. So it means that we can suppose the partial pressure of H2 is equal to 1. Let's suppose the partial pressure of hydrogen is equal to 1. At that time, the partial pressure of HI is equal to 28 at that time. Now, actually, what will be the partial pressure of iodine? They are having same mole ratio. I mean, we can compare the ratios of the reactant and mutually ratio of the reactant and ratio of the product. So it's 1 mole. It is also 1-to-1 ratio. So its answer will be also be 1. So the partial pressure of H2 is equal to 1. Partial pressure of iodine is equal to 1. I am going to write the expression of Kp. Kp is equal to partial pressure of H2 multiplied by partial pressure of I2 divided by partial pressure of HI raised to power 2. So it's equal to 1. Again, for iodine, the number is same 1 divided by what is the partial pressure of HI, that is equal to 28. 28 raised to power 2. So 1 divided by 28 square. 1 divided by 28 square, and the answer is, 1.28 into 10 to the power minus 3. So A is the correct option. A is the correct option. Next question. 1 molecule of hemoglobin Hb can bind with 4 molecules of oxygen according to the following equation. 1 mole of Hb is going to react with the 4 mole oxygen, 1 and 4 mole of oxygen to give 1 mole of hemoglobin. When equilibrium concentration of oxygen is 7.6 into 10 to the power minus 6 mole per dm cube, the equilibrium concentration of hemoglobin and oxyhemoglobin are equal. What is the value of Kc for this equilibrium, and so on. So what should be the answer of concentration of hemoglobin at dynamic equilibrium? You know that the ratio between hemoglobin and oxygen is equal to 1:4. This hemoglobin is 4 times smaller, 4 times less as compared to the concentration of the oxygen at that state of dynamic equilibrium. Oxygen ratio hemoglobin, and there must be the oxyhemoglobin. The answer of oxygen 7.6 into 10 to the power minus 6, and hemoglobin answer will be equal to 7.6 into 10 to the power minus 6 divided by 4. 7.6 into 10 to the power minus 6 divided by 4, and so on. They are having same concentration, and the concentration of oxygen is 4 times higher as compared to the hemoglobin. So what is the answer of Kc? Oxyhemoglobin, what is the answer of this oxyhemoglobin? That is equal to 7.6 divided by 4. 7.6 into 10 to the power minus 6 divided by 4. And the answer is 1.9 into 10 to the power minus 6. 1.9 into 10 to the power minus 6 divided by, again 1.9 into 10 to the power minus 6. And for oxygen, 7.6 into 10 to the power minus 6 whole power 4. So what is the answer? They will be cancelled out, and we will get 1 divided by 7.6 10 to the power minus 6, and 2.99 into 10 to the power 20. Yes, almost 3. into 10 to the power 20. A is the correct option. A is the correct option. Next question. 1 mole of phosphorus chloride, PCl5, is heated at 600 Kelvin in a sealed flask of volume 1 dm cube. Equilibrium is established and measurements are taken. PCl5 goes to PCl3 plus Cl2 and so on. The experiment is repeated with 1 mole phosphorus chloride heated at 600 Kelvin in a sealed container, and now this time the volume is equal to 2 dm cube. Initial volume was 1 dm cube. Now this is repeated at higher volume. Higher volume means smaller the pressure. I mean half of pressure is over here. When we reduce the pressure, equilibrium will shift toward that side where there are high number of mole, more number of moles are there. I mean by reducing the pressure, we will get the more concentration of PCl3, Cl2. How will the measurement vary? Equilibrium concentration of PCl3 and Cl2 are higher. No, PCl3 is not higher. Equilibrium concentration of the PCl5 is lower in second. Yes, it is true. Yes, it is true. I mean B is the correct option. However, let me check the other one. Equilibrium concentration of all these gases are same in both experiment. No. The value of equilibrium constant is higher. No, equilibrium constant will be changed only by changing the temperature. Next question. When copper is added to a solution of silver ion, the following equilibrium is established. Cu solid plus Ag aqueous plus Cu2 aqueous plus Ag 2 mole of Ag solid. Kc is given. What is the concentration of silver ion at equilibrium when copper 2 ion concentration is 0.1 mole per dm cube? First of all, write the expression of Kc, and this time solid will not be included. So, copper 2 positive ion concentration divided by silver ion concentration, that is in aqueous form, raised to power 2 because of 2 moles. And Kc is given, that is equal to 1 into 10 raised to power 5. And the concentration of Cu2 positive ion is also given 0.1 mole per dm cube. So 0.1 mole per dm cube divided by, let's suppose that the concentration of silver is equal to, silver ion is equal to, is equal to X raised to power 2, and that is equal to 1 into 10 raised to power 5. So X square will be equal to 0.1 over 10 raised to power 5, 10 raised to power 5, and what will be equal to the X? The final answer is 1 into 10 raised to power minus 3. 1 into 10 raised to power minus 3. So C is the correct option. 2 mole of compound P were placed in a sealed container. The container was heated and P was partially decomposed to make 2 products, Q and R only. A dynamic equilibrium between P, Q and R was established. At equilibrium, X mole of R were present and total number of mole, that is equal to 2 plus X by 2. What is the equation for this reversible reaction? So the easiest way out to exercise to try all these 4 options turn by turn. Number 1, P goes to 2Q plus R. Initially 2 moles of P is over here, 0 mole of Q, 0 mole of R initially. At this time of dynamic equilibrium, 2 minus Y goes to 0 plus 2Y, and R, 0 plus Y. At the stage of dynamic equilibrium, the mole of R is equal to X. So it means that Y is equal to X. So put X where there is a Y. 2 minus X goes to 2X comma X. And now I'm going to find the total moles. Just to confirm the total mole, that must be equal to 2.2 plus X by 2. So the total moles, 2 minus X plus 2X plus X. So the answer is 2 plus 2X. That is not the case. sum of total mole at the stage of dynamic equilibrium must be equal to this one. Come towards the next option. This one, I'm going to write it over here. 2p goes to 2q plus r. Initially, it is equal to 2 mole, 0 mole, 0 mole. 2 minus 2y, this time 2 is over here, goes to 2y and just y. Again, you know the y is equal to x because it is given in the question. So 2 minus 2 into x goes to 2x and x. So 2 minus 2x plus 2x plus x. This time the sum of mole is equal to 2 plus x. Again 2 plus x, that is not the required one. Come towards the next one. I'm going to try the next one, this C. 2p goes to q plus r. 2 mole, 0 mole, 0 mole initially. 2 minus 2y and y, r is again y. In this case, y is equal to x, put y is equal to x, 2 minus 2x, this y is equal to x, this y is equal to x. So the sum is equal to just 2. So again, third one option is the incorrect. It means that the fourth one will be the correct one. I'm going to write it 2p is equal to, goes to q plus 2r. 2 moles initially, 0 mole, 0 mole. 2 minus 2y goes to 0 plus y, and this time 0 plus 2y. Now, in this case, the answer of r is equal to x mole. So 2y is equal to x and y is equal to x by 2. So in this case, put y is equal to x by 2, x by 2, x by 2. So 2 minus 2 into x by 2 plus x by 2 and 2 into x by 2. So there will be cancellation. Minus x and plus x will be cancelled out. Remaining mole will be equal to 2 plus x by 2. That is the required one. So it is confirmed that D is the correct option. The next question. In an experiment, 2 mole of hydrogen and 3 mole of iodine were heated together in a sealed container and allowed to reach at the equilibrium. In this question, once again, initial moles are given. Container had a fixed volume of 1 dm cube. At equilibrium, 2.4 mole of iodine present in the reaction mixture. What is the answer of Kc? It's a simple question. Initially, we are having H2 and I2 to HI. Hydrogen is equal to 2 mole and we are having iodine is equal to 3 mole and 0 mole of HI present initially. So, step 1 is to write the mole. Step 2, I'm going to start from the very beginning. You can say I'm going to apply all the steps. And the next step is 2 minus y, comma 3 minus y, 1, 1, 1, and here 0 plus 2y, 0 plus 2y. At the stage of dynamic equilibrium, there were iodine is equal to 2.4. Remaining mole of iodine is equal to 2.4. 3 minus y is equal to 2.4, and y will be equal to y over here and 2.4. 3 minus 2.4 over here, and that is equal to 0.6 if I'm not wrong. 3 minus 2.4, that is equal to 0.6, yes. So y is equal to 0.6, put y is equal to 0.6. 2 minus 0.6, that will be equal to obviously 2.4, it's given over here, goes to 2 into 0.6. So 2 minus 0.6, that is equal to 1.4. 1.4, it's 2.40 and is 1.2, right? So what is the expression of Kc? Kc is equal to Hi square, concentration of Hi raised to power 2 divided by concentration of H2 raised to power 1 divided by concentration of I2 raised to power 1. Hi concentration square, 1.2 square divided by 1.4 into 2.40, right? So I'm going to write it over here, 1.2 square and divided by 1.4 multiplied by 2.4. And the answer is 0.428, 0.249. Yes, C is the correct option. C is the correct option. That's all about today. Thank you very much. Have a nice day.